This video presentation is brought to you by the Pro Mathematics Academy.
Okay, so without further ado, guys, I'll jump right in. So the first question asks us to define secant h of x, which is our hyperbolic sec function, and tan h of x, which is our hyperbolic tan function. Guys, please, all microphones off. The only microphone that should be on is my microphone. So please be respectful of everyone. We don't want to have interference while I am trying to get the topics or the concepts across. Right? So we jump right in. Recall that sine h of x, right, is equal to e to the x minus e to the minus x divided by 2, and cosine h of x is equal to e to the x plus e to the minus x divided by 2. From this, we can define the secant h function, which is our hyperbolic sec function, as the reciprocal of our cosine h of x. This then gives us what? 2 divided by e to the x plus e to the minus x. Right? And from this, we can also define tan h of x, which is equal to sine h of x divided by cosine h of x. This then simplifies out to e to the minus x, e to the x minus e to the minus x divided by e to the x plus e to the minus x. And there we have completed question number 1. Now, why are these questions important? These questions are particularly important because every year you are tested on the definition of your hyperbolic trigonometric functions first. So we want to always keep these definitions in mind. Questions like these will be on your final exam. All right. So do we have any questions regarding the first question? Guys, please, after I finish working out each question, you can ask or comment, all right? If you don't understand something, don't be afraid to interject, okay? So I think for question number 1, this was fairly simple. Let's jump right into the second part, right? The second part asks us to use the definitions to show that for all x in R, secant h squared of x is equal to 1 minus tan h squared of x. So this is a proof. And you know, when we're proving things, we want to start with either the left-hand side or the right-hand side and work it all the way to the other side. So for this, I begin with my right-hand side since we have more stuff to work with. So this means we have 1 minus tan h squared of x is equal to 1 take e to the x minus e to the minus x divided by e to the x plus e to the minus x all squared. And that's coming from the definition that we previously wrote down. This then gives us 1 take e to the x minus e to the minus x squared divided by e to the x plus e to the minus x all squared. Now, I know that at this point we're tempted to expand both the numerator and denominator, but for this question in particular, what you want to do is you want to try to see if you can simplify it without doing too much expansion, right? So if we do the expansion, it might take us a very long time. But what we're gonna do is
Class meeting. The class.
Guys, remember I was trying to explain or stating that we don't want to have our microphones on, okay? So please be mindful of everyone to keep your microphones off. Nice. So let's jump right back into this question. So what we want to do is we want to take this one and we want to write it as e to the x plus e to the minus x squared divided by e to the x plus e to the minus x all squared there minus e to the x minus e to the minus x squared divided by e to the x plus e to the minus x squared. So the only thing I changed there a while ago was I took this expression, right, which is equivalent to this 1. So basically I'm rewriting 1 as the quotient of two things that are the same, and that thing came from this denominator. Nice. So if we look at this expression, I think I have to minimize my working out that I'm doing so far. So let's see if I can minimize this. Hopefully you guys won't have too much of a problem with that. All right. So zoom in on this. So now what we want to write this as, we want to take our, let's do it over here. We want to write the numerator as e to the x plus e to the minus x squared minus e to the x minus e to the minus x all squared, all divided by e to the x plus e to the minus x all squared. And if you look at your numerator, what you'll realize is that we have the difference of two squares. And that's the reason why I didn't want to go ahead and perform the expansion, because I realized that here I could do the difference of two squares. So this then gives us as our numerator e to the x plus e to the minus x, right? Plus e to the x minus e to the minus x in one bracket. And in the other bracket, we have e to the x plus e to the minus x minus, so let's do us inside expression here, e to the x minus e to the minus x. And that is all being divided by e to the x plus e to the minus x squared. So if we simplify our numerator further, what we realize is that we have what? 2 e to the x times 2 e to the minus x. So I know that some persons are wondering how we got that. Guys, I'm just simplifying my numerator. So this then comes out to be 4 divided by e to the x plus e to the minus x all squared, which is the same as 2 divided by e to the x plus e to the minus x all squared, which is equal to sec squared h, well, sec h squared, which is our hyperbolic sec function squared. So I can say that this is done. And guys, it's also important for you guys to attempt the question, right? It's also important to attempt the question if you feel that's the best way for you to get into the meat of the problem. But if you also just want to see the solution, then that is fine. All right, so do we have any questions regarding this particular working out? Guys, remember, if you have any questions, please shoot a message in the chat room first, right? And then from the chat room, I will call on you to ask your individual questions. All right, so I guess there are no questions regarding this particular working out. So let's check the, I see we have people waiting. Let's just add these people really quickly. Nice. It's difficult to navigate between my shared screen and the Zoom app. Nonetheless, I guess there are no questions, so I will be moving right along. Guys, please remember to turn your microphones off. The only microphone I should be, well, only microphone that should be on should be my microphone. So please be respectful of everyone else. So for persons who are just joining, the session is being recorded, so don't worry about what we have already completed, all right? So jumping into the next question, right? This question says we are to prove that the cosine inverse hyperbolic function is equivalent to ln of x plus the square root of x squared take 1 for x, an element of all real. All right. So why this particular question is of importance now, guys, is the fact that on the exam, you will be asked to find one of the inverse hyperbolic functions, okay? So if not cosine h, you can be asked to find the inverse of tan h, or you can be asked to find the inverse of sine h, all right? So we need to know how to do these type of proofs. So let's jump right into this one. So we know how to find the inverse function, right? The technique that we use is called the line technique. I don't know if you guys call it that. So once you're finding the inverse of a function, we use what we call the line technique. So the first thing in the line technique says let y equal to f of x. All right, then we interchange x and y. Then we make y, well, we don't make y, we actually make x. Make x, no, we make y the subject. We make y the subject of the, let's say, equation, could say formula. Then we express y as f inverse of x. Okay, so this is basically my roadmap to what I'm supposed to use when I'm trying to find the inverse function of a function from C-set days. Okay, guys, this is all C-set mathematics. Now, let's jump right into the question. The question says y is equal to cos h of x. So I guess I need some more space here. Just move this down a little, right? So y is equal to cosine h of x. So this means we can write this as y equals e to the x plus e to the minus x divided by 2, right? So our first step would be to interchange, well, our second step would be to interchange x and y. So interchanging gives x equals e to the y plus e to the minus y divided by 2, right? So let's transpose or make y the subject. Making y the subject, we have, this implies that 2x is equal to e to the y plus e to the minus y, which means that 2x is equal to e to the y plus 1 divided by e to the y. Then we multiply through by e to the y. So this means that e to the y times 2x is equal to e to the 2y plus 1. Right, so after multiplying through by e to the y, we end up with this equation. So bringing everything to one side of the equation gives e to the 2y minus 2x e to the y plus 1 equals 0. So if we look at this equation, we realize that what? Hey, we have a quadratic in e to the y. So can we use our, how can we make y the subject of this formula? Or rather, how can we make e to the y the subject of this formula? How can we make e to the y the subject of this formula, guys? Guys, make sure you're making notes as you go along, okay? Because sometimes I have to switch in between the Zoom app and the note writing app that I'm using, right? So we notice that we have a quadratic in e to the y. So we can make e to the y the subject of this formula by using the quadratic formula. So we all remember the quadratic formula, right? I'm sure we all do. So here, we're gonna say that e to the y is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So since we have a quadratic in e, oh my God. Guys, microphones, please. Nice. So using the same formula, we have e to the y equals 2x plus or minus the square root of 2x squared minus 4 times a. What is our a in this question? 1. Minus c. What is our c in this question? Also 1. All divided by 2 times a. What is a? 1. So simplifying this expression gives us e to the y is equal to x plus or minus the square root of x squared minus 1. Yeah, man, I need you guys to ask some questions on this one. All divided by, well, I guess that went into the expression. So this means that y is equal to ln of x plus or minus the square root of x squared minus 1. This means that f inverse of x is equal to, f inverse of x is equal to what? Let's see who was paying attention when I was using when I was writing down the line technique. We have what? F inverse of x equals ln of x plus or minus the square root of x squared take 1. But have I proven what the question asks to prove? Not yet. This means that f inverse of x is equal to ln x plus the square root of x squared minus 1 or ln of x minus the square root of x squared minus 1. So here we have two possible answers for f inverse. And then we take, what was the question asking us to prove again? Nice. So we take cosine h inverse of x to be ln of x plus the square root of x squared minus 1. And then we say that is a q. Hello. I see somebody's trying to ask a question. Hello. Intech, we are not hearing anything you're saying. And it seems we have 10 minutes remaining in this session. So guys, I'm gonna ask you to, when the session closes, I'm gonna ask you to just log back into the same link, okay? Intech, or I believe that's what your name is in the chat room. We cannot hear anything you're saying. So please try to type your message in the chat room and then we can get back to you on that. So for this particular result, guys, notice that here we have two possible functions for f inverse of x. Excuse me, sorry. Notice that we have two possible functions representing f inverse of x. But here I chose cosine h inverse to be that one. All right, so that's something for you guys to think about. I would love to hear your guys' opinion on that result. How did I move from this line, which is my f inverse equals two possible functions, into cosine h inverse equals to that? So, okay, I'd love to hear your guys' thoughts on that result. Live from the chat room, guys, go ahead. We only need one person to give their thought on that. Okay, I guess everybody is nervous. Nobody wants to say anything. Don't want to seem like they don't know anything. So I guess I'll move right along until we are ready to start expressing our ideas. All right, so the next question that we have for you here. All right, so let me try and tidy this up a bit. All right, so we move to this question, which asks us to find the exact value for the arc length of the curve y equals cosine h of x between 0 and ln of 2, right? And note they gave you the formula, even though you guys learned this formula in Calculus 1. The examiner was kind enough to give us the formula here, which says that the formula for the arc length is L equals the integral from a to b of the square root of 1 plus f prime of x squared dx. Okay, so using this formula, we can find the length of an arc, or the length along the function f of x. So here we have the function f of x equals cosine h of x, right? So if we know f of x is cosine h of x, that means f prime of x is equal to sine h of x. Guys, please recall those results. Okay, the derivative of cosine h of x is equal to sine h of x, and the derivative of sine h of x is cosine h of x. Let's write that down. All right, so those are some results which we want to keep in mind. Nice, so let me just put them over there in that corner. Moving right along, so we have these two results. So this means that 1 plus f prime of x squared is equal to 1 plus sine h of x squared, right? And from our identities, we know that 1 plus sine h of x squared is equal to what? Nice. We know that 1 plus sine h of x squared is equal to cosine h of x squared. So now our formula L equals the integral from 0 to ln 2 of the square root of 1 plus sine h of x squared dx is actually equal to the integral from 0 to ln 2 of cos h of x dx, right? And everyone knows what this result is because we just explained what are the derivatives. So of course the integrals must also be the same. See that we still have persons waiting there in the chat room. So on my clock, I am seeing less than a minute. So guys, I'm going to end the meeting and you guys are gonna log back in exactly 30 seconds, okay? Nice. Okay. And we're back online. So as I said, guys, please be mindful of everyone else who is here to learn. The only microphone that should be on should be my microphone, okay? So I know I'm hearing somebody else's microphone right now. Nice. So here we're trying to find the arc length of this integral. And we got the formula from the question, the integral from 0 to ln 2 of the square root of 1 plus sine h of x all squared dx. When we evaluated it, this is what we got. The integral from 0 to ln 2 of cosine h of x dx. And when we integrate cosine h, we all know that we end up with sine h of x, right? And we have to evaluate this between ln 2 and 0. So our answer seems to be sine h of ln 2 minus sine h of 0. This then gives us sine h of ln 2 as our final answer. And this can be simplified further just in case you guys are wondering, but if you're in the exam and you gave them sine h of ln 2, that would also be fine. But just in case we are curious, we see that this comes out to e to the ln 2 plus e to the minus ln 2 divided by 2. And we know that sine h of 0 is 0. All right. So in case we were wondering, that's just a reminder. So this then means we have 2 plus 1 over 2 all divided by 2. Oh no, something is off here, guys. Something is off here. Our definition of sine h is actually e to the x minus e to the minus x. So here this would be 2 minus a half divided by 2, which gives us 3 over 2 divided by 2, which is equal to 3 over 4 units. All right. Any questions as it relates to this question? Guys, remember, you guys are encouraged to ask questions inside of our chat room. I don't see anyone asking any questions there. See if we have persons to admit. Take 9. Oh my God, you guys are crazy. All right, Mr. Tech 9, I see you. Just gonna mute your audio there. The person who is S. Awesome. So, as I said, guys, you guys are encouraged to, oh my God, you guys are over there like zombies. So, inside of the chat room, if you guys have any questions, you can ask them at this time regarding any particular step that I made, right, in evaluating this integral. I guess there are no questions, so I will be moving right along slowly. So our next topic is actually differential equations. We covered that before we went off on our holiday or our Corona break. So we jump back into some differential equations just to refresh our memory. Well, let me just organize this. I thought I made enough space for all of these. Nice. So this question says, solve the equation dy dx plus 2 divided by x times y equals 6x squared. Now, when we see a differential equation of this form, we are to remember that these type of differential equations are called first order linear. And we've been doing them since we were doing CAPE mathematics, right? So some of you guys should be familiar with differential equations of this form or this nature, right? So what is a first order linear for those who are wondering? Once you have a differential equation that is in this form, dy dx plus p of x times y equals q of x, then we say that this differential equation is a first order linear differential equation, okay? So we have to look out for that form. So here we recognize that for dy dx plus 2 over xy equals 6x squared, px is equal to 2 divided by x, and qx is equal to 6x squared. So once you can identify what is px and qx, you can conclude that this differential equation is indeed a first order linear. All right, so we have to be able to recognize that because this type of differential equation in particular normally comes on the final exam. All right, so how do we solve a linear first order differential equation? We use what we call the integrating factor. All right, so that should ring a bell to a lot of you guys. So we use the integrating factor approach here, which says that f of x, right, the integrating factor is defined as f of x equals e to the integral of px dx. So once we can find this integral, we take the integrating factor. So let's say that the approach to solving this equation is 1. Find the integrating factor, and then 2 multiply through by integrating factor, okay? So if f of x is equal to the integral, no, not the integral, is equal to e to the integral of px dx, then this implies that here our f of x is actually e to the integral of 2 over x dx. And when we integrate 2 over x, we end up with what? This implies that f of x is equal to e to the 2 times ln x. Hello, is that correct? I think so. So this gives us f of x equals e to the ln of x squared, and that's applying our rule of logarithms right there. You guys with me? So then we see that f of x is equal to x squared. So that means x squared is our integrating factor. We have to take our integrating factor and multiply it into our linear first order differential equation. So now 2 multiplying through by integrating factor gives x squared times dy dx plus 2x y equals 6x squared times x squared, which simplifies out to x squared dy dx plus 2xy equals 6x to the 4th power. Now, when we look at our left-hand side, we recognize that the product rule was performed. And this part is particularly interesting. We look at our left-hand side and we realize that the product rule was performed. What product rule, sir? We performed the product rule here on this expression, x squared times y. So if I perform the product rule on x squared times y, performing implicit differentiation, of course, we realize that the expression we would get would be exactly this expression. Right? So if we perform the product rule on x squared times y, as in we take the derivative of x squared times y and performing implicit differentiation, we end up with x squared dy dx plus 2xy. All right, so that means we can rewrite this expression, x squared dy dx plus 2xy, as the derivative of x squared times y. So this then gives us 6x squared. So we can, I guess I was using a lot of space here. Let's see if we can minimize some of this. See if we can minimize some of that. Nice. Right? So we integrate both sides. Integrating both sides gives us the integral of d dx of x squared y dx equals the integral of 6x to the 4 dx. So as you know, integration is a reverse process of differentiation. So this just gives us x squared y equals the integral of 6x to the 4 dx. Integrating 6x to the 4 power gives us 6x to the 5th power divided by 5 plus c. So this then means that y is equal to 6x to the 5th power. Well, I guess we can subtract the indices here. This gives us to the 3rd power divided by 5 plus c x to the minus 2. And that is our answer. Do we have any questions as it relates to this particular question? You guys are welcome to ask questions at this time. I realize that nobody wants to ask any questions. So, okay, I see we have someone who turned on their microphone. Is it that you have a question? Hello, Sebastian. I don't know if it's Sebastian or Tech9 that have their, I guess both of them have their microphone on. So I'll just close out Mr. Tech9 right there. And I'll close out Mr. Sebastian right there. All right, so see that there's one person waiting in the meeting room. So someone said minus, sir, x squared. So I guess Jordan Ashman. Jordan Ashman, you're welcome to make your inquiry. Jordan Ashman, you can go ahead and turn on your microphone and let us hear you express your concerns vocally. I guess Jordan Ashman got his covered there. Was when we were doing the sine function. Interesting. So we have an inquiry from Pookie. Scroll to the top part of my answer. Okay. Let's see if we can bring that up. I'm not sure where would be the top part of my answer, but I guess if I'm showing everything, the top part of my answer should be showing. Yes? All right, Pookie. So I'm sure that whatever it is that you're looking for should be there.
Sir,
Yes, I see we
I've
have someone voicing their opinion.
I've a friend been waiting for you to add him to the call, sir. Can you add him, please?
Okay. And what's the name of the person? I don't have anyone waiting right now on my waiting list.
Oh, never mind, sir. Say add him.
Okay, awesome. All right, guys. So I'm gonna ask everyone to turn over into the chat menu right now. Go over into the chat, and what if you realize I just sent you a link? I want you guys to go over and hit the subscribe button to receive future notification as to when this video will be posted. Okay, so this session is actually being recorded, and I'm gonna be posting it on the Pro Math Academy YouTube channel. I'm asking you guys to just go over there and hit the subscribe button right now. Okay, before we go into the next question, go ahead. Also for our session tomorrow, which will be formal mathematics, the same approach. All right, so for those videos, guys, you guys want to be notified whenever I post them. So please go over there, lend us your support. Just hit the bell icon and also hit subscribe. All right. Cool. So we're jumping right into the next question, right? Which asks us to perform, well, to solve this differential equation, right? Hold on, let me just tidy up this a little bit. So let's take this down. Let's take this down some more. All right, I think we have enough space here to work this one, but just in case, let's bring this down a little bit. Let's bring this one down also. All right, so it says find the equation of a curve that passes through the point 2, 1, which has a gradient, which has at each point xy, the tangent line with gradient dy dx equals x squared minus y squared divided by 2xy. Hold on, let's see if there's anybody waiting in the meeting room. No. Okay, right? Find the equation of a curve that passes through the point 2, 1, which has at each point xy a tangent line with gradient dy dx equals x squared minus y squared divided by 2xy. So this question is basically asking us to solve this differential equation. Now, of particular importance, guys, we need to be able to recognize that this differential equation is a homogeneous differential equation. How do we know when a differential equation is a homogeneous differential equation? So in much the same way that I defined a first order differential equation for you, here I'm going to define for you what is a homogeneous differential equation. So before we define a homogeneous differential equation, we have to know what is a homogeneous function or a homogeneous equation, right? So let's say that you have a function f of xy, right? If you can show that let's move this. If you can show that f of xy, well, not f of xy. All right, let's write this out properly. So if given a function f of xy and f of lambda x, right? Let's write that in properly. F of lambda times x, comma, lambda times y equals lambda raised to a power n times f of x, your original function, right? If this result is true, then your function is said to be a homogeneous function, right, of degree n. So I can say then f of x, y is a homogeneous function of degree what? N. All right. So it's a homogeneous function of degree n if we can show that this equation holds true. So if we plug in lambda x wherever we see x, and we plug in lambda y wherever we see y, and then somehow we can manipulate that into factoring out a lambda out of it, then we realize that, hey, this function is indeed homogeneous. So likewise, if we're given a differential equation dy dx equals x squared take y squared divided by 2xy, right? Dy dx equals lambda x squared minus lambda y squared divided by 2 times lambda x, right? Lambda y is equal to is equal to what? I can take out lambda squared out of this first part. So that's lambda squared times x squared minus y squared. And I can also factor out lambda squared out of my denominator. So this becomes 2 times x times y. So this simplifies out to, so both lambda squares cancel and we're left with lambda raised to the 0 times what? X squared take y squared divided by 2xy. So we see that we use the homogeneous property. Well, we were searching for the homogeneous property and we ended up with a homogeneity of degree 0. So this is actually a homogeneous function, a homogeneous equation. So we know that this differential equation, once we test it with the homogeneous condition, which is what I defined for you here. So that's the homogeneous condition. Once we test it with a homogeneous condition and we realize that it is indeed a homogeneous function of degree something, then we can make a substitution. So this is what the theorem says, and this theorem is related to solving homogeneous differential equations. So it says, if given a homogeneous differential equation, f of x, y equals dy dx, right? Or let's say dy dx equals f of x, y. Same thing, right? This part is important. Then substituting what? Substituting v equals y over x. V equals y over x makes the differential equation separable. And we all know that separable differential equations are the easiest type to solve, right? So something they don't tell you about this theorem is that when you're substituting, you actually have to make 2 substitutions. So dy dx is equal to v plus, well, let's actually derive this. So we have to substitute for both v and we have to substitute for dy dx. Okay? So let's actually derive this part. So y is equal to vx implies that dy dx is equal to the first times derivative of the second plus the second times the derivative of the first. So here we have to make 2 substitutions. The second substitution is that we have to substitute dy dx equals to x times dv dx plus v. So we substitute v equals y over x and we also substitute for dy dx equal x times dv dx plus v. Once we make those 2 substitutions into our differential equation and simplify, then we end up with a differential equation that is now separable in v and x, all right? So now, back to our original differential equation, dy dx equals x squared take y squared over 2xy. So wherever I see y, I'm just going to substitute y equal v times x, and wherever I see dy dx, I'm just going to substitute dy dx equals v plus x dv dx. All right, so those are the 2 substitutions I'm looking for. So let's go. So this means dy dx is equal to x squared take, in bracket here I put vx squared divided by 2 times x times vx making those substitutions gives us, well, we didn't substitute for dy dx here, so let's do that. So this means we have v plus x dv dx equals x squared minus x squared v squared divided by 2v x squared. So is it possible to cancel all the x's from my right hand side? Indeed. So this then means that v plus x dv dx is equal to 1 minus v squared divided by 2v. Are you guys with me? Nice. So we then want to transpose to make dv dx the subject here. Or rather, we're trying to separate this, we're trying to show that this differential equation is now separable. So after making the substitutions, you manipulate your differential equation into something that is separable. So this then gives us x dv dx is equal to 1 take away v squared divided by 2v minus v, right? Which means that x dv dx is equal to 1 minus v squared over 2v minus 2v over, well, 2v squared over 2v. Nice. So there I basically manipulated or transformed my v and rewrote it as 2v squared divided by 2v, which is equivalent to v. So no rules violated there. So this then means that, what does this mean, guys? This then means that we now have x dv dx equals 1 minus 3v squared divided by 2v is equal to our left-hand side expression, which we can still simplify. Well, now we're going to try to put all the v's on one side and all the x's on one side. As I said, the equation is now separable. So this means 2v divided by 1 minus 3v squared is equal to dx divided by x. So somebody's wondering where the dv went. dv is still on our left-hand side. So there we realize that the equation is now separable. And somebody's wondering if this theorem works all the time. Yes, this theorem works all the times. Okay, guys? So once you have a homogeneous differential equation, then making the substitution y divided by x equals v always gives you a new equation that is separable. I realize that we have less than a minute to go inside of our session. So I'm going to ask you guys to log back in exactly 30 seconds, okay?
That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.